Hello everybody and welcome to another video. In this video, I basically want to introduce different ways that you could represent loops. One way I showed you is a loop that counts up, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That will help you produce numbers 1 to 10. For example, if you want to do something 10 times, that's one way you could do it, was counting up, having your initialization start at a number and then going up. You could also have another loop which counts down. So it's basically the opposite. So you could do 10, you could start at 10 and then switch your condition to be I is greater than or equal to. In this case, when do I want to stop? I want to go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Um, I want to stop when I get to 1 because I want 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then I can do I minus minus. Meaning count down. So I is 10, then I'll become 9, I'll become 8, 7, 6, 5, and then we'll get to 0. And that's when the condition and the loop will stop, meaning that we've successfully printed and done something 10 times. We can count if you want. That's 3, 4, 5, 6, 7, 8, 9, 10. That's just another way you could write this program. There's also the idea where you could do like 40 and then go to I is less than or equal to 50, I plus plus. Um, Again, this number basically will just do the same thing. It'll print the number. It will go to 40, 41, 42, 43, 44, 45. But if you plan to, let's say you plan to use the starting value later on, it probably is not going to be a good idea to start at 40. Let's say you're counting a file and each line dictates the order in which you receive the file. You're probably not going to start at 40 and go to 50. You're probably not going to start at 300 and go to 320. You're probably not going to do some random math like that. You probably just start at 0 and then go to however big the file length is, and then just keep going up. Um, so that's just the idea of what you could do with loops, different ways that you could represent loops, and different ways that in which you could write the same program a different way, as long as your loop follows the same structure. For example, if you want to do something 10 times, there are different ways in which I could get to the number 10. I could go from 100 to 110. I could go from 100 to 90. I could go from 75 to 85. That's just basically the idea of loops. And I just showed you one way, which is counting up. You can also count down. You could also multiply things. For example, I could count by 2. For example, I could do I plus equals 2, meaning count by 2 every time. Let's see how much that runs. That ran 3, 4, 5, 6 because it goes 40, then 42, 44, 46, 48, and then it goes 50, and then eventually it will hit 52, and that's the 7th iteration. So that's just why it counts up by 2 every time. You could also do I plus I times equals 2. So this loop will only run one time. That's because it will go 40, and then it will go 80, and then 80 is less than or equal to 50. Hopefully, you understood the idea of for loops and different ways in which you could represent the same behavior, in which they could do different things, and common math equations you could use to get to the same value. That's just the perks of using loops because there's different ways to solve the problem. I hope you understood that they're possible, and I'll see you in another video.